Let's see the solution to question number 3. The question says, the population of trees in a forest has been decreasing by 6% every 4 years. The population at the beginning of 2015 was estimated to be 14,000. If P represents the population of trees T years after 2015, which of the following equations gives the population of trees over time? Well, notice that we're talking about first is a decreasing pattern. Okay, so take a look at this. A decreasing pattern that has a fixed percent of decrease per year or per period of time means an exponential decay pattern. So let's try to visualize this, okay, in a chart in the following manner. This is the time or the number of years passed after 2015, while this is the size of the population. An exponential decay follows this pattern graphically, okay? Where this value here is the initial size of the population at the beginning of the mapping of the values. That is at period 0, which in this case would correspond to the beginning of 2015. Okay, so let's try to identify some data here, okay, in order to put together the equation that connects P and T as variables. So what is the initial size of the population? The value of A would be 14,000. Okay, very good. Remember, we're aiming at an equation of the sort P equals A times 1 minus X percent up to the number of periods of time. Okay, where X is actually the percent decrease per every period of time. So we have A. According to the statement, it says that the decrease percent is 6% every 4 years. So we have our value for X. X is actually 6%. Then what about the time? Notice that according to the number of years, we need to consider that the decrease by 6%, that is multiplying the original size of the population by the factor 1 minus 6%, which equals 24%, multiplying A by 24% should be done every 4 years. So the number of years passing must be divided by 4 in order to determine, okay, the number of times which this factor will be multiplied by the original population. For example, if the number of years passed, T, is 4, then you will increase or decrease the original size by 6%. After 4 more years have passed, then it will be decreased again by 6%, and so on. So that means that the decrease will happen when T equals 4 years, 8 years, 12 years, and so on. In order to determine, okay, this correctly, the value of this exponent here should be the number of years divided by 4. Because, for example, when T equals 4, then 4 divided by 4 will be 1. And percent decrease of 6% will be applied to the population. Then, when t equals 8, a divided by 4 will be 2. So that means that you will have a new decrease of 6%. Okay, so now we see that this exponent needs to be t over 4. This matches precisely, okay, this equation. P equals 14,000 multiplied by 1 minus 6%, that is 24% or 0.94, up to the number of times that this percent decrease will occur. Okay? It will occur once every 4 years. So t, the number of years passed divided by 4. This will be the correct equation. Matches option D.